Greetings and welcome to Flanigan's Ecologic. I am your host, Ted Flanigan, and today I'm joined by Paul Gipe. He's a friend and a world-renowned wind power expert. For 4 decades, he has analyzed the renewable energy industry. He has written numerous books. He's lectured extensively, and as you will hear, he is a dedicated advocate. Paul also is passionate about EVs, and we'll hit on that too. Hey, Paul, welcome to the podcast. It's great to see you.
That's good to see you too, Ted.
And are you sitting in home office in Bakersfield as we speak?
Indeed, Bakersfield, Kern County. Yes, sirree.
one of the great areas of wind.
Well, it's the oil capital. It's the oil capital of California for sure.
But don't you get some wind up in Kern County then too?
Well, we do, but that's in Tehachapi, and I'm down here in Bakersfield.
Yeah, okay. You know, I was thinking about the wind industry. I'm reading all about all these offshore floating wind turbines I want to ask you about, but would you just say we've come a long way, baby, with wind? I mean, look at the size of these turbines going in now.
Well, I've always argued that the machines that we had were good enough to do what we needed to do. They're much better now. They're much more cost effective, obviously. And they're much more efficient. And they're finally designing the wind turbines in a way that we can begin to put the wind turbines where we need them, not necessarily where it's windy, but where we need them, where the people live. And that's the important development. It's not offshore. It's not the giant wind turbines. It's that how we're now designing the wind turbines enables us to put them into places closer to where the load is, closer to where people live. For example, around the Midwest. Midwest is of the United States, the heartland. It's not known for wind energy, but it is now. They even got wind turbines in my hometown of all places.
No, but you're making a critical distinction, I think, here between the massive utility scale wind projects and then more community scale. Is that right?
No, not really. No, I'm talking about the massive wind farms. Yeah, in central Indiana, for example, they have massive wind farms. They have no community wind farms. I mean, it is Indiana after all. I mean, it's a red state. They don't believe in that community stuff. You know, that's all for us greenies out here in California, or a Dane in Denmark, or a German in Germany, where they're only too happy to own their own wind turbines, their own solar panels, and make money off renewable energy. But that's not what's done in most of the United States, including big green California. No, these are commercial wind turbines. They're, just as big. They're just not as big as the ones they put offshore, which are incredibly huge.
Right. Now, you mentioned the design of the turbines has advanced so they can be closer to the load, like in the Midwest. What have they done with the design?
They could have done it 30 years ago. People like myself have been advocating that they design the wind turbine not for the size of the generator, but the size of the rotor. If you have a big rotor, you can have a small generator because, as you know, it's the rotor that captures the wind. It's not that electrical part that's at the top of the tower that makes wind energy. It's the big spinning part that makes wind energy. And if you put a smaller generator on a big rotor, you get a lot more electricity from it in places with low winds. And we've known how to do this, 30 or 40, probably since the 1920s, really. But industry finally has woken up to the fact that this is the way to build wind turbines so that we can put masses of wind turbines, many, many big wind turbines, where the people are, where the load is. Then you don't have to build as many transmission lines. But it's not rocket science.
So you're just expanding the blades. The blades are getting longer and longer on these turbines to pick up the lower wind speeds.
Yeah, exactly. I mean, I talk about it in my books. Of course, people have to read books to kind of get that message, but the industry is doing it now. And one reason that the industry is doing that is because we've already put the wind turbines where it's windy. So the places that are left, it's just not so windy. So you have to begin to confront that. How do you get enough energy, wind energy, out of a place that doesn't have a lot of wind to make it cost effective? Now, we've known how to do that for 30, 40 years, or maybe since the 1920s, but they're finally doing that. And that's the big story. So, for example, if you see a press release from General Electric or Vestas says, wow, we have a wind turbine that has a 50% capacity factor. And I go, yeah, okay, we know how to do that. That's not exciting. We know that. It's okay. It's because we've finally realized how we need to design wind turbines so that we can use them everywhere.
I think about California. We had the San Gorgonio Pass, we had Tehachapi, and we had Altamont. And those are the primo locations in California, right? Hot air temperatures in the desert, rushing air through those passes and vice versa. And now you're saying that because we have gotten smart, or the industry's gotten smart, expanded the size of the diameter of the rotors and the length of the blades, that now we're off in these other areas and we're picking up lesser wind patterns, but we're doing it effectively. We're generating power.
Yes, we are. And for example, just a couple of weeks ago, we went to the Salinas Valley, and there's half a dozen big wind turbines in Salinas Valley. Now, they're not in wind farms like you see around Tehachapi or the Altamont, but they're in distributed applications. For a prison, for example, a couple big turbines at a prison. There's one for Taylor Farms. You probably buy Taylor Farms bagged salads there, wherever you happen to be, Orange County or something like that. And Scheid Vineyards, the big vineyards have them. We were visiting a mission in the Salinas Valley, and there was Scheid Vineyards' big wind turbine over there spinning. Wonderful sight. That's the way it should be. And it's not windy in the Salinas Valley. It's better than, say, Bakersfield by far, but it's not a windy place. It's not like Tehachapi or the Altamont Pass.
I've seen those wind turbines when you're going up the 5 and, or whether 101, I guess it is, in Salinas, south of Salinas. And I guess they're cost effective. Otherwise, they wouldn't be there. And you're saying that that's largely because the designs have changed, become more appropriate, and our costs must be coming down as well, right?
Well, of course, as they make the wind turbines bigger, they cost more money. But yes, the cost per kilowatt hour that's produced by the wind turbine is decreasing. Up until now, I think we've reached a plateau. I don't think you're going to see a lot of decreases in the cost of wind energy. In fact, I think you might see the cost of the wind turbines actually going up because a couple of the manufacturers, at least in the Western world, not in Asia. I mean, China's just still, producing windmills like crazy. But a couple of them manufacturers, for example, Siemens is in financial trouble because, they were selling the wind turbines too cheap. They were, bidding into projects. And so when you bid in, you try to underbid the other guy, and they bid too low. Lots of companies bid too low. That's why some of those offshore projects were canceled on the East Coast. They bid too low. And I've been a critic of bidding too low. I'm a critic of bidding in general. But Siemens got caught with their pants down on that one. So I don't think that we're going to see a lot of improvement in the cost of commercial wind turbines. I think we've reached a plateau. You might continue to see that in solar because it's a completely different technology. It's not a machine. It's electronics, and we're banging out hundreds of megawatts every couple of months now of solar. So it's completely different technology.
What about with wind is supported by the production tax credit still today, doesn't it?
Correct.
And do you advocate for that?
It's not my preferred mechanism for developing wind energy, but because I'm an American living in the United States, that's what we got. So, okay.
Well, would your preferred mechanism be a lucrative feed-in tariff?
Yes, it would be, not necessarily a lucrative feed-in tariff, a fair feed-in tariff, so that companies like Siemens won't get caught where they're on the edge of bankruptcy and ask the German government to bail them out. I mean, this is a big company, and they're asking German taxpayers to bail them out because they bid too low on some projects, and they ran into some technical problems with their blades. They're getting bigger and bigger. Well, they didn't do adequate testing on the blades, and so they ran into problems, and the problems are very expensive to fix, particularly offshore. Very expensive to fix stuff offshore. And so there's a couple things there. One is, of course, they're in a bidding system. The other is they're trying to make their money offshore. Mm-hmm. And that's not where wind energy is really going to make a difference. Okay, so maybe we can get 10% of our electricity from offshore wind energy. Mm-hmm. That's good. We need to do it. The fact that it garners all kinds of press doesn't mean anything to me, because mm-hmm. It's not that important. It's useful. We need to do it, particularly on the East Coast, where there's major load centers: New York City, Boston, the DC area, Charlotte, North Carolinas. Those are all big load centers. And maybe we can put some offshore Florida, assuming that they remove their ban from wind turbines in Florida. But we'll need a new governor to do that. But it's not going to be where the majority of wind generation occurs, offshore. I've been a critic of the emphasis on offshore in the media and in the wind industry, because it's seen as a panacea. Well, people don't want to look at a windmill, and you have the right wing who say, oh, well, they're starting to cut into our profits, so let's create some organizations to stop wind energy on land. Well, then, the wind industry says, oh, we'll put them offshore. People won't complain about them. But that's not true. You put them offshore, they're still going to complain. It's not a panacea. So we still need wind turbines on land, and the majority of wind generation will come from wind turbines on land.
Paul, what about, I want to get back to the big stuff, and I want to talk floaters in a second here, but you've brought up this whole notion of distributed wind production, just like I'm a huge advocate of distributed solar production, that we need it all. We need the bigger installations, but we also need household, residential. Is wind happening at the residential level or at the community level? I know you perhaps not in Indiana, but is it happening in some states?
Well, my friend and colleague Mike Berge will certainly be critical if I say no, it's not happening. I mean, he continues to sell wind turbines and continue to install them for homeowners, farmers, ranchers across North America. Mm-hmm. But that doesn't make a big dent in what we need to do to deal with climate change. We need a lot of wind generation, and we need it now. And the kind of distributed generation that you and I prefer or would like to see happen is not happening in the United States. It's not happening in Canada. It's not the way we do things here in North America.
It seems to me we need it all, right, to address the climate issue. So, but if you lived in an area that's got a decent wind regime, like Victorville, California, for example, you go up there, there's all these. Have there been advances with those really small turbines as well as the large turbines that we were talking about?
Well, there has been in the last decade. I think in my last book, I make a big point. The previous book, I was real critical of the small turbines, and then I said, okay, they've actually gotten a lot better. They're almost twice as cost effective, almost twice as efficient as they were 20 years ago. So that's a big improvement. But distributed generation is much more than just some small wind turbines at somebody's house or at a ranch. Distributed generations are like those big turbines in the Salinas Valley that are at our factory. And so you mentioned Victorville. Well, that's another example of distributed generation. There's several cement plants there that now have wind turbines. Yep. And it's the same company that did them. I'll forget the name of them, but they're the ones that did it in Salinas. They've done some turbines in the Antelope Valley at the prisons, and it's very, very difficult to do what they're doing. And they're not doing many. I would say right now we're probably less than 24 wind turbines in distributed applications by that wind company, all told, probably a couple dozen.
This is a hard question, but you're used to answering hard questions. I mean, is there a wind speed that is required if you're a homeowner or if you're living in a community that would make wind a better option than solar?
Well, right now, once again, Mike Berge is not going to be happy with me. When people call me and say, it's windy where I live, what kind of wind turbine should I have? And I say, just put up solar. It's just so cheap. It's so easy. It's so simple. You just do solar. And if you need more than that, okay, we could talk windmills. Happy to talk windmills. But yeah, you probably need something like 12 miles per hour. I mean, if you're going to press me to throw out a number, and I'll throw out a number. Average annual wind speed of 12 miles per hour would be rip snorting good for a small wind turbine.
Uh-huh. And how about for a big wind turbine?
We could probably make it work. I mean, I would like to think that we can make it work. The Salinas Valley, I've been doing some research on early wind turbines that were put in the Salinas Valley. I didn't even know they put wind turbines in the Salinas Valley back in the 1980s. And I'm learning all this stuff. Well, they put them in there, they didn't work, but mostly the wind turbines didn't work. But they actually put in a project of wind turbines that were, workable wind turbines. They, legitimate company built hundreds of the things. I think there were 500 of this particular wind turbine in California at the time. They put 4 of them in the Salinas Valley, put them in a lousy place. They didn't produce much electricity. A half to a third of what the wind turbines that U.S. Wind Power was using in the Altamont Pass. And so the project failed. The wind turbines eventually were reused. They were put back somebody bought them, shipped them up to the Altamont, and they put them up there. But it's not a windy place by wind industry standards. And so they're making it work. They're making it work with, they're trying to find all the angles to make it work. One of the angles is these are behind the meter, in that these are large factories. They, make salads and stuff, and prisons. Of course, it's large electrical load at the prison. And so they're offloading consumption. So they're not competing against a gas-fired power plant that says they can produce electricity at 5 cents a kilowatt hour. No, they're competing against the retail rate. And the retail rate in California is, I don't know what LADWP pays down there, but up here we're paying almost 40 cents a kilowatt hour. So
yeah. Let's go back offshore for a second. You're surprising me on a number of fronts, which is why I enjoy these podcasts so much. But offshore, and you've said you think that the potential is maybe 10% of the U.S. load. What's your read on the floaters? I mean, I talk about press attention. They're getting lots of press attention. These floating wind turbines that I guess that seem appropriate for the West Coast, where we have no continental shelf. It drops off. What's your read on floating wind turbines?
Well, I first need to tell you, and of course any of your listeners, that I've been wrong many, many times in my career. And another example where I was wrong is when the first idea of having floating wind turbines was proposed. I said, nah, that's not going to happen. Just think of that. It's a giant machine that's rotating in the wind, and you're going to have it sway with the waves. Well, okay. Yeah, I guess they can make it work. And so they've proved me wrong again. That they can actually do this and make it work. Will they make it work economically? That is still a question. And so the jury's still out. I think there's a project going in the UK's offshore waters. I think the Swedes or the Norwegians had put some turbines up that were floaters. But yeah, for the West Coast, it's going to have to be floaters. Floating wind turbines, and I think the jury's out. I mean, it's not going. I don't think they're going to be super cheap, but it might. But the big thing about offshore for the West Coast is these are in depressed areas that have been reliant on fishing, and the fishing industry is dying. Well, it's like dying everywhere. And these are places that we already have the grid connections. We have power plants. Take Morro Bay over there on the west coast of California. Morro Bay, there was a oil-fired power plant, gas-fired power plants, abandoned things. Of course, they never tore it down. It's still standing there. But you got the electrical connections there, so you could do both servicing offshore from a place like Morro Bay, where Diablo Canyon, for example, but you can also bring the electricity onshore because the wires are already there. So that offers tremendous advantage because the infrastructure is not all there, but an important part is there. So, and the same thing in Oregon. So I don't know about Washington State, but certainly, Oregon, those fishing communities, they're harbors. The harbors could be developed to service the offshore industry, and you may have to build some transmission lines or upgrade them and so on, but that's okay. That's fine. And Diablo Canyon, no matter what Newsom does, is eventually going to be turned off. So there's a lot of big, very big wires that go to Diablo Canyon, and that's another place we can bring in offshore wind energy.
I've been reading about wooden turbine towers, turbine towers made out of wood. And I think in the United States, steel production is about 3% of our emissions, our greenhouse gas emissions. And so obviously we're all looking at reducing use of steel and use of cement and other these energy greenhouse gas intensive industries. Do you see potential for wooden turbine towers?
Well, I mentioned it in my last book because well, we have a forest industry in North America. We had a forest industry in North America on the East Coast, servicing the newsprint industry, the paper industry. Of course, that's collapsed because people don't read newspapers anymore. Blah blah blah. But we still have those industries. We still have those forests, which were designed for pulp paper production, and the Quebecois, the Canadians, have been doing some work in this, and they thought this was going to be a big opportunity for them to build components, wooden components, with plastic materials, laminates, for wind turbines. And the same thing has been done in I think, Sweden. Sweden still has a forest industry. Same thing, pulp mostly, but it's there. So, and my book, I wrote my book was 10 years ago. So we're still just seeing prototypes. So I was pretty far out in front on that one. I'm not sure it's going to make a big difference. Remember, keep in mind, these wind turbines are what, $5 to $10, $20 million a piece. They're so big now, they're very costly. So what insurance company is going to insure a whole bunch of wooden wind turbines that haven't been used before? Who's going to insure it? Because we don't have any experience. So, one or two. And in the meantime, the industry is just going as fast as it can. Well, we want it to go as fast as it can. And maybe the wood stuff will come along, but it's not there yet.
Hard to imagine. I mean, aren't some of these wind turbine towers the height of the Eiffel Tower, or even taller than the Eiffel Tower?
Yeah, no, they're big.
So hard to imagine wooden turbine towers supporting that. But
I know. I mean, we're not talking about like the stick constructions that we have of our homes in California. These are engineered materials. They're high quality wood laminates. Well, maybe you don't know this, but I'll address it as this. You already know this. We had built a lot of wind turbine blades out of wood, and they were really big. But I think that factory was eventually closed. It was on the Isle of Wight because they could actually ship blades from the Isle of Wight easier than from Brighton or Portsmouth or something like that. And that was a major manufacturer of wind turbine blades. Maybe up until 10, 15 years ago. And those blades to you and I physically were huge, but they were wood laminates. We call it composite material. So it's not all fiberglass, a lot of fiberglass, a lot of epoxy materials, but also wood fibers.
Yeah.
So the blades, which are something that's flapping in the wind, wood is good material for them, or wood composite's good material for them. So, it's conceivable.
When I sent you the draft list of questions for this podcast, you fired back, we should be talking about EVs. And then I got the impression that you were not going to even join the podcast unless I was driving an EV, which I appreciate your radical nature, of course. And I was lucky enough to be able to say I do drive an EV. Why are you so passionate about EVs, Mr. Gipe?
Well, because you and I both know, and probably many of your listeners know, wind and solar, they're here now. We just need to build it out. Now, of course, the United States, Canada, North America, we're not growing fast enough. The Chinese are running rings around us. The Germans are running rings around us. Anyway, but so we've accomplished that. We have a technology that works. We have solar and wind. It just needs to be deployed on a massive scale. But the thing that we haven't mastered yet is transportation. Transportation is a major source of emissions. And there's no easy solutions to it unless we just stop burning stuff. That's what we have to do. We just have to stop burning stuff. Forget all the discussion. Just stop driving combustion engine vehicles. That's it. And like 20% of our emissions come from transportation. And of course, in the United States and Canada, that's predominantly from vehicles on highways, not from trains. I mean, we can easily electrify trains. We should have done that, of course, 30, 40 years ago. But again, we're Americans. We live in North America. We haven't done that because we have a lot of diesel fuel and we have big diesel engines. But, we could put a catenary up there and run our trains on electricity, but we really need to move to electric vehicles. So I was quite impressed that you said you've been driving an EV since 98. So how did you do that?
Well, I was at LADWP. I was the director of energy efficiency, or we called it the Efficiency Solutions Group, and we had a fleet of EV1s. I guess originally it was originally the EV Impact, right? The GM Impact, but then they decided that budding sounded like a car crash. So that was part of my job, was driving around LA, and but it's been, I guess, for me about the past 7 years that I've been 100% electric, and then Terry got an EV also. So we're a 2 EV household, and one of the things that I get a kick out of is letting people drive my EVs, the people that haven't been in an EV, because they're just fun to drive. And all you hear about is, the limitations, which is the range, right? And the EV charging deserts and all that, which is, a lot of that stuff is getting taken care of, but they're so peppy. You can actually get yourself out of danger zones. You accelerate quickly. What is it that you like best about your EV?
Well, that's exactly what I tell people. It's brought the joy of driving back to driving. It's like being a teenager again when you first got your license. It's like, whoa, hey, this is fun. It can be fun. And it hasn't been fun for many, many years. But if you get an EV, almost any kind of EV, you're going to find out it's a lot of fun to drive. And in addition to that, of course, you can charge it at home. I mean, I can't remember the last time I've been to a convenience store. Geez, you just don't go to those places. A gas station, I don't know. Maybe they have an EV charger in the back. Okay, I'll go to that. But you charge at home. It's just so convenient. You go to sleep at night and you wake up in the morning, your car is fully charged. I mean, what's not to love about that? For me, it's a no-brainer, really. I mean, we can talk about all the specifics and stuff. And all these, and when you're talking to people who aren't convinced and they come with all their objections, and I just say, you can't beat it, really. You're going to drive one. It's the way cars should have been from the beginning. Now we have the technology can do that. Of course, in your very, very early days of automobiles, they were electric.
Yeah.
And it wasn't until now, of course, another senior moment. I forget one of the early car developers for General Motors developed the automatic starter that gasoline powered and diesel engines became the most popular because you could have an automatic start and you didn't break your arm trying to start the thing.
That's right.
So that was a big improvement.
I think it was Henry Ford's wife that was driving an electric vehicle. It only went about 20
miles
exactly,
because women preferred it because, well, they didn't break their arms trying to start the damn thing.
Paul, when you mentioned how peppy they are, I don't think, and I have a Chevy Bolt, we also have a Tesla, I don't think I've ever put my foot all the way to the floor to floor it. I mean, if there's a place down here where I'm getting onto the 134 and then the 5 where I like to just zoom, but I've never floored it. I have no idea what it could do, but it's pretty extreme, I think.
The tires will chirp if they don't spin. I've been at a stoplight in Bakersfield, and in Bakersfield, we got some pretty big trucks out here, and they got the big pipes. And of course, if they see a Prius, they put the black smoke out. Well, they don't even recognize the Bolt as an electric car, so they don't do that to me. But they're at their stoplight revving their big engines, and I'm off. And, they catch up to me to the next light, but, I stop for the light. I don't know if they do or not.
That's great. Hey, listen, I wanted to ask you, I saw on your website that I think it's on May 8th that you're doing a wind and wildflower hike up near Tehachapi. Is that right? Do you do that every year?
Yeah, it's on the Pacific Crest Trail. This will be our 38th year.
Oh my gosh.
And we're going to go for 40. I hope I can make 40. But anyway, yeah, it's a real hike. It's 7 miles. This is not just a stroll in the park. We don't spend a lot of time looking at the flowers. We do look at the flowers, but it's not a botanical hike. I have to advise people. I'm involved with the Botanical Society here in Bakersfield, and those kind of things, you're crawling on your knees most of the time. But no, this is a real hike, and we've been doing it forever. And every kind of wind conditions up there: snow, sun, blistering heat, freezing cold, hail. We've done it all, and we did it. We started it originally. I mean, I started it originally because there were people in Tehachapi said windmills are terrible. They're going to kill everybody, and they're going to drive us all into the sea or whatever. And I said, well, let's go. The Pacific Crest Trail goes right through the heart of the wind farms in Tehachapi, and I like the desert. I'm from back east. And, they have lots of trees back there. But when I came out here, I said, wow, look, you have a spectacular view of the desert. And the trail follows a trace of the Garlock Fault. And so on one side, on the east side, you have the Mojave Desert. On the other side, you have the Tehachapi Mountains. And, of course, all around you are spinning wind turbines. So for me, it's like, wow, this is a dream come true. And so it's a really great opportunity to get out and enjoy California and what California has to offer. And we have, beautiful wildflowers in the spring. And up there on that hike, that section of PCT, there's a thing called the grape soda lupin, Lupinus excubitus. And when it's in full flower and it's a good year, like it should be this year, the fragrance from those is just overwhelming, and it smells like grape soda. It makes you really thirsty.
Oh, great! I'm going to try to join you this year.
Yeah. After this, I'll send you the details so you know exactly where to go. Well, I think if you saw the press release, yeah.
Yeah, I'll be able to get there. But hey, thanks so much for being on the podcast today.
It's a pleasure, Ted. Good to see you again, and good to talk to you.
That's it. Thanks for listening to Flanigan's Ecologic. We'll see you next time.